A push-pull amplifier consists of two transistors. One is an NPN, the other one is a PNP, NPN and PNP, and they are connected in such a way that they are both connected between the output and a 0-volt configuration. The bases are biased through resistor, sometimes diodes are put in there, but a resistor or a voltage divider grouping, so that they are placed as class AB or class B amplifiers. We will also see that this circuit has a positive supply voltage as well as a negative supply voltage, so we're going to need a dual power supply configuration in order to have this circuit operate. Now, when we're connecting this circuit, the moment we connect the circuit, these two resistors will bias this transistor and place it in the active region, and these two will do the same for this transistor. Now, the result is such that when I connect a sine wave on my input, as my input voltage increases above my 0-volt reference, the biasing that occurs will turn this transistor more on. As a result, this transistor will become more conductive, and conversely the bias will turn this transistor more off. As a result, I will get this signal on my transistor there, and because this is more on, its voltage decreases and it becomes close to 0. When I go into the negative half cycle, this transistor turns more on, and as a result its voltage becomes close to 0. This transistor turns more off, as a result its voltage turns more on, or its voltage increases. Now, in this configuration, this output is the combination of those two input voltages. Now, if this is a class AB or a class B amplifier for the NPN and the PNP, then we will find that the output signal that's going to combine is going to look like that. That's the NPN transistor that's operational or amplifying, and this is the PNP, this is the PNP transistor amplifying, that is the NPN transistor amplifying, and we will get that configuration. The problem is that with a class B configuration on these two transistors, at that point over there, I get what is called crossover distortion. That crossover distortion occurs because for a short moment in time the transistors are not both operational, because this transistor is switching off while this transistor is switching on. As a result, there's a small little piece of distortion occurring over on that crossover there. So when we replace the values of these resistors in order to allow these two transistors to operate as class AB amplifiers, what actually occurs is my class my NPN transistor will work during that range, or amplify that range of voltages, and then this PNP transistor will amplify that range of voltages. The result is that for this section in time, from there to there, we've got both transistors operating. So as a result, as one of them turns completely off or completely on, what occurs is that the other one picks up the slack, and that overcomes the crossover distortion. When it comes to the frequency response curve, we will have the same as for the RC coupled amplifier. We've got our medium frequencies, wide range of operation at our high frequencies, and our low frequencies we get the drop off values. That level there is 0 decibels, and that level over there is my -3 level, which is my half power. Formulas that we need to consider is the same as with the normal RC coupled. Current gain equals 20 log output current divided by input current. Voltage gain 20 log output voltage over input voltage. And for my overall gain, my power gain, 10 log output power over input power.